g of x equals the square root of x plus 6 minus 4. All right. So we look at this. Here's it. All right. This parent function, the parent function for this graph is what? The square root of x. So we know that we'll just call it f of x the parent function. All right, and this is number 9, I believe. So the parent function is square root of x. So you need to know what that looks like. All right, and in fact, on this one, I graphed the parent function just because it makes it a little bit easier. All right, so the parent function square root of x. All right, I just started the next side as I know. X equals 0, where the square root of 0 would be 0. Square root of 1 would be 1. Square root of 2, I don't really know. Square root of 3, I don't really know. Square root of 4 is 2. 5, don't know. 6, no. 7, 8, no. 9, square root of 9 is 3. All right. That's about as far as I really need to go. But so I know that the square root function looks something like that. Okay. Now we were talking about transformations on Friday. All right. This x plus 6. What is this right here going to? How is this going to transform this function? 6 units to the left. All right. So this x plus 6 is moving this graph 6 units to the left. Left 6. Every question? It's moving every point on the graph to the left 6 units. What is this part doing? It's moving down 4. All right, hold on. I got someone who thinks it'll be done for fun. So again, when we say that this function is moving left 6 units and down 4 units, that means every point on this graph is moving left 4, down 6. So that's why I like to graph this out. Because until you get really good at it, at knowing like the sort of patterns in the functions, okay, it makes it easy to be able to do this. Here's a point right here that I just put on here. It's going left 4 units, down 6, or left 6 units, down 4. So this point right here is going 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. So at that point, well, yeah. So it's going to give us negative y value. So this point moves down to here. This point is now going to go left 6. 1, 2, 3, 4, 5, 6. Then down 4. 1, 2, 3, 4. This point. Left 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. This point. Left 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. There's my graph. Each point moves. That makes sense. Alright. Again, until you get really good, alright, it does make it a little bit easier if you graph at each point. Alright? Because personally I can say, okay, well I know this point moves here, and that doesn't go to 1, and then I can figure out how far up it goes. Alright? Question? No question? Alright. Makes sense. Alright. Let's look at another problem. Alright, so main race is 1 in there. Alright, so the function for number 13. Is it 13? Yes. Alright. Is g of x equals 1 over x minus 6 plus 8. Okay? So, identify what parent function is this? Huh? What's it called? It's called the reciprocal function. You guys look, I forgot that I was supposed to make a quiz for you now. Parent function quiz today. Parent function quiz on Wednesday now. Okay? So you guys know what the parent functions look like. That's all this is going to be about. Alright, so we know that the parent function for this is 1 over x. Alright, so f of x is equal to 1 over x. Alright, so you have to know how to graph this. Now, in order to graph this, well, what happens here is that, okay, it's having some fraction problems now. So I'm going to make 1 be every 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. Alright, so every 4 is going to be here, and 1, 2, 3, 4. Alright, 1, 2, 3, 4. 1, 2, 3, 4. That's 1 and 2, 4, and 1, 2, 3, 4. Alright. The reason I do that is because this one involves fractions. Alright, I know if I put in like 2 here, it's going to 1 half. If I put in 3, 1/3, 4, 1/4. Alright, so I'm going to put in 1. When I put x equals 1 in there, it gives me 1. When I put x equals 1/2 in there, it's going to give me 2. Alright? When I put x equals 1/4 in there, it's going to give me 4, so it's going to be way up here. Alright? When I put x equals 2 in there, it's going to be 1/2. It's going to be like right there. And then if I put, and so forth, so it's going to go to something like this. This graph looks something like that. Okay? Ooh, this is going to be bad though. Alright. I have to count my words here just because the graph, I just feel like I've moved it 6 and 8. So there's going to be 1 and 1. This is going to look something like this. Long run, as long as it looks like that, we're good. Okay? So, here's what we found. Here's an easy way to figure out how to graph this. Alright? We see that there's a break right here. Correct? And we see that there's a break right here. Which we're going to learn about. This is called a vertical asymptote. This is called a horizontal asymptote. We kind of talked about horizontal asymptotes already. And vertical asymptotes is discontinuity. We kind of talked about those. But we go more in depth, so in a couple weeks. So what we are looking at here is that this is going to move up 8 units. So this whole function is moving up 8. And it is moving right 6. Make sense? So really all I need to do is I need to move, as long as I move the brakes, because there's no stretching. It's 1 over x minus 6. There's no stretching in it right now. Alright? So as long as I move the brakes, this graph's still going to look the same. It's just going to be the vertical asymptote will be somewhere different. It'll be 6 units to the right. And the horizontal asymptote will have moved up 8 units. So here's how I can do this. So this horizontal asymptote is moving up how far? 8. So 1, 2, 3, 4, 5, 6, 7, 8. I know that there's going to be a break right there. This is going to be my horizontal asymptote, moved up 8. I know that my vertical asymptote, this vertical break, is going to move 6 units to the left, or to the right. 1, 2, 3, 4, 5, 6. So I know there's going to be a break. Right there. Okay? So what I know is that at this point, we're going to shift all the way up to here. And this point right here, we're going to shift all the way to here. Alright, because it's shifting. Because this right here is negative 1, negative 1. It's going to go over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7. my graph. Number 3. That makes sense. You can also check your graphs on Desmos. You can check your graphs on Desmos, you can check them on the graph calculator. Now 20 through 30 apparently were the same thing, except that they were involving more of the sort of stretching, changing the shape of the graph. So do we want to look at any of those? So why don't we look at, so 24 says this, all right? says g of x equals 3 times the absolute value of x minus 4. First thing it says is identify the parent function. What is the parent function for this graph? Oh. So the parent function would be the absolute value of x. Good. Okay. Now, it then says, describe how the graphs of g of x, which is this one, is related to f of x. So, Sean, what is one way that this graph of g of x is changing from f of x? It would be moving right if it said that. Because what would have happened was our parent function, which is the absolute value of x, okay, was replaced with x minus x. It's only moving left or right if you take your parent function and replace this initial x with like x minus 4 or x minus 2. Right? So the only time it's moving left or right is if you replace the actual x with x minus something and x plus x. So what is this one actually? Going down, how many units? Going down 4 units. So so it's asking you, okay, g of x is shifting down 3 or 4 units. Okay? What else is happening? Can be stretched. Remember, it's compressed if what? If the value that you're multiplying the function by is between 0 and 1. It's stretched if it's greater than 1. Right, so what you look at is this. So think of it this way. This is saying that this is saying essentially your parent function is y equals absolute value of x. Well, what we did here was this 3 is multiplying that by 3. 3 times the square root of x. If I multiply one side by 3, I have to multiply the other side by 3. So what's happening really is that right there, 3 times the absolute value of x, is taking every y value of absolute value of x and multiplying it by 3. So if my y value is 1, it's now 3. If my y value is 2, it's now 6. If my y value is 3, it's now 9. Okay? So what you get is you get a function that is a very skinny v. That has been moved down 4 units. Alright? equations. What are the things we want to see? 28. Okay, 28 is a similar type of problem that's used by Lysander function. It says that g of x is equal to x, the greatest integer function of x minus 2. So first of all, what's the parent function? Now I have to do the greatest integer function. That one I don't like that much. Yeah. Wait, there's the one that goes open circle, line, circle, closed circle, jump, open circle, close. I've never seen the one. I think it's been in the book some other time. We just might have decided to problem like that. I think it's right. So that's what that is though. So it's the greatest integer function. That's that. So Leilani, what is one way that this graph has been changed from the parent function? Going what? Okay. So Leilani says it's going down by 5. Is it? I'm assuming that you got that from negative 5. All right. Is that really moving it down 5? So when you have a number, so think of it like this. We're going to sort of build on this. All right. We have, so f of x is the same as saying y. All right, so this is going to say y. We're going to build on this right here. I have no idea. Yeah, you want to. That's why I don't like using it, because I don't know how to draw. Alright? So the first thing that we have, let's look at this. You have that 5 right there. Okay? That, and this time, let's worry about the negative sign. We put a negative sign outside of this whole function. Alright? If I multiply this side by a negative sign, I have to multiply this side by a negative sign. Negative sign. Alright? This negative sign does what to the graph? What's happening to all the what? All the positive y values are now what? Negative. So all the stuff that's up here is now, it reflects across the x-axis. Alright, all the stuff that was down on the bottom in the negative sign has reflected to the top, which is now positive. So what axis does that reflect over? The x-axis. So g of x has reflected across x-axis. Now, Leilani. So the negative 5, so the negative sign reflects across the x-axis. Alright? Now, it says negative 5 times this. So, what I did was I had that negative, and I have 5 times that. 5 times y. So what's happening to all my y values? What are they being multiplied by? They're being multiplied by 5. So there's everything. So if it is at 1, it's now stretching up to 5. If it is at 2, it's now stretching up to 10. Okay? So this whole thing is stretching vertically. Right? So it stretches vertically. What we say is stretches vertically by a factor of 5. Alright, stretches vertically by a factor of 5. Right, now, we said if we take this x and we replace it with something, it's moving left to right. If we put the minus sign or a plus sign outside of that original function, it's moving up and down. What happened here? This This x minus 2, yes, it's moving right. So shifting right. 5 units. Okay. Yes, and then back up to it. So what we're going to do is this. All right. I think that because I want you guys to be good at this. All right. So what we're going to do is we are going to have some practice with this. All right. And what I'm going to do is I'm going to use Desmos and I'm going to put something up on the board. All right. And I'm going to do one of two things. Okay. I'm going to either put in two functions where you cannot see where you can only see the parent function in the equation, or the parent function in the graph, and you have to write down how is that function changed and what the new function is. I want you to actually write down the function. So if it's shifted to the right, you can have like x minus 2, and then up 4 plus 4. All right. So what you're going to do is you're going to come up with the equation. So if I give you two graphs, you have to tell me what the parent function is. You have to tell me how is the parent function, how did you change the parent function to get the new function, and what is the new function. Okay? If I give you just one graph and an equation, you have to tell me how is that graph changing, and you have to graph the graph. Does that make sense? Yes? All right. So what I'm gonna do is I'm gonna have to be tricky up here. I'm going to actually let's see something. Again, I want you to figure out what the parent graph is, and I want you to tell me how the red graph shifted to get to the blue graph, and I want you to come up with the new equation for the blue graph. All right. So, Nick, what parent graph is this? What parent function are we working with here? Quadratic. F of x equals x squared. Huh? Square graph, that's technically not the name of the parent function, but I know what you mean, but we want this. So it's f of x equals x squared. Now, all right, how is this function, Brianna, how is this function, is this function moving left or right? How far? 5 units. And then, Mo, how many units is this moving up or down? How is it going up or down? Down 4 units. All right, so, and does anyone have an equation to like the function for this? Jalen? Yes.
Where is the x plus 5 squared minus 4?
Correct. X plus 5 squared minus 4. Again, you can be checking your answer on your calculator. All right. Does that make sense there? All right. We're gonna do one more here where we deal with just shifting it left and right. Then we'll start getting into some of the other ones. All right. So, let's see. Okay. So time for the next. All right. So again, you guys are coming up with the parent function. I want you to tell me how far how to shift the parent function to get to the blue function, and then I want you to come up with the equation for the blue function. All right. All right. We're gonna have Lucas. Go ahead and attempt this one. So, everyone listen up to Lucas while he talks. All right. It is a reciprocal. Okay. Do I have to say it? Tell me everything. Okay, the function is f of x equals 1 over x. All right. It shifted right 3x and up 2. Okay.
And on the actual thing, I didn't tell me where to put it. I did, f of x equals 1 over x minus 3 plus 2.
Good. All right. 1 over x minix 3, because it should be 3 to the right, plus 2 because it's going up. Alright? How do we feel about these right now? These are easy? Alright. So I'm gonna put up another one. This time, well not yet. This time what I'm gonna do is I'm going to mix in reflections and stuff. All right, here we go. Yes. So, you need to tell me again, the parent function, you need to tell me whether or not this graph has moved left or right, and how far, if it's moved up or down, how far, and whether or not it has reflected at all.
It went down big fast.
Sure. I'd probably start with reflected first.
And then you move it down. How do you work that?
All these positive x, all these positive y values are changing to negative. So I just put a negative sign.
I hate that. That's more complicated than life. Negative x, and then plus minus negative divided by times that by. I wasn't involved in that conversation. Shut up. I did right. For anyone else. Oh, God. Look at it this way. Oh my God, you do it. Because I feel like I'm facing it. Now I don't want to eat it.
So, here's what I need. David, Ronaldo said that he wants to try this. So we're gonna let him explain. All right.
And the new function f of x equals the negative square root of x plus 4 minus 5.
Good. So he said the new function would be f of x equals negative square root of x plus 4
You gotta put the negative sign out.
minus 5.
You stay outside the right.
So let's think about this real quick, guys. Let's think about this. First of all, the reflection affects the y value, right? And moving it up and down affects the y values. The only thing that's affecting the x values is the stuff that's in the x minus or x plus something. So one way to think about this is to take your graph, and we know, okay, our parent function is f of x. Okay, I know something's going to change. F of x is another fancy way of saying y. So my y values, if it reflects across the x-axis, all my y values become negative. So I know that I need to put a negative sign up front. Okay? Now I know that it's also shifting down, it's moving down 5 units. Alright, so I know that's moved down 5 units. My x values, they're moving to the left 4. So I know it's going to be x plus 4. So then I can take all this, and all I'm doing is replacing f with my actual function coming out as negative, my function with the square root function, and then it's going to be x plus 4 minus 5. Okay? So, now I'm gonna step up the degree of difficulty now. Okay? Because what we need to do is, we need to look at what happens when we stretch something. Okay, the black function is the parent function. I need you to tell me what the parent function is, and I need you to tell me, try to figure out what the equation is. Okay? The black function is the parent function. I need you to try to figure out what the equation is for the red function.
I got this. It's stretched in one.
Did it shift left or right? Okay, did it move left or right? Did it move up or down? No, it didn't move anywhere. So really the only thing that has changed is I have put some number in front of this equation.
I'm doing this. This is my final answer.
I'm going to flip it off real quick. I'm going to put something up here that I think may help.
Bro, I just flipped the whole graph. Oh, right. I didn't want super negative. I got, oh my God, what the hell is this? I am not capable. I got this. Wait, let me see your graph again.
All right, here. So I put some points on there now. Look at the x values and look how the y values compare. How they be related. Look at the y values and try to compare how the y values compare for each x value. 1, 1, 1, 3, 2, 4, 2, 12.
No, it's 3. No, it's 3. There's the points up there. 3x squared. I'm tired.
The idea is here. Leilani. So let's have Leilani tell us what she got.
I got 3x squared.
Leilani got 3x squared. So Leilani, what parent function is this? Quadratic. And then you have, and then you notice, how did you get 3x squared?
Because I noticed that the y value, like you multiply the black and the red on the bottom, and times 3 would be 6, and the fourth on the 8 is 12 for the top.
So what's happening here is each y value, f of x, each f of x value is being multiplied by 3. So it's 3 times f of x. What was f of x? F of x was the parent function x squared. So it's 3 times x squared, or 3x squared. All right? Yeah, negative. So, Michaela asked a good question. She asked, could it ever be negative 3x squared? Well, Michaela, you tell me. If I type in negative 3x squared, so here's the graph 3x squared, right? What's going to happen? If I type in negative 3x squared, you'll notice that the red graph just flipped across the x-axis. So it flex across the x-axis. All right. Here's what I need you guys to do. All right. I need you to come up with your own equation now. Nope. So actually, here's what we'll do. Okay. You guys have, each of your tables have to come up, so each of you have to come up with a graph. I'm going to give you 2 minutes. You have to come up with one function to try and stump the other tables. And I come up with one to try and stump you guys.
Oh, that's not fair.
Nah.
You don't pick the hardest one.
I'm going to that one fraction. With the box. Do that.
You even know how to do it?
Right, I'm doing square root. Now, if you start off here, line, the one we have not done. What happened? No, we got everything like that.
You guys need to take it so you need to come up with one equation to try and stump the rest of the class with.
Can I do one to make you mad?
No.
Oh, I can't do that one. Circle.
Okay.
Oh, I got the marker out. Alright. I don't even know my phone card, bro. I just want to do.
Yeah.
No, each person at the table, can you have another?
So here's what I need you guys to do. I need you to focus up here now. Focus up here. Focus up here. All right. I have this function up here. All right. So first of all, what we want to try and figure out what the equation is of this function. So what is this parent function that what parent function are we working with? Typical function, which is 1 over x. Okay, so we know that f of x is equal to 1 over x. That's our parent function. Right, so let's see if we can come up with this together. So f of x is equal to 1 over x. Now, this is going to be a little bit more challenging. Okay? First of all, this function right here, I gave you some points. What do we notice about this function, like in terms of moving left to right and moving up and down? Huh? What do you mean about negative?
Negative y.
Okay, well, did this graph, first of all, did this graph
Move.
what happened to this graph?
Move. I don't think it's good.
What do you mean reflected? How do you know it reflected?
Oh, because that is probably a real
Typically, 1 over x. All right, and this is where it comes into play because this is going to be on your quiz. You have to know what the parent function looks like. 1 over x. I'll put that up there real quick. All right. Now I don't want you guys to see the equation. Just have to do this real quick. All right. So 1 over x, and that's a good thing to recognize there, Michaela, is yes.
Can they rotate?
Any type of rotation that we can do would be a reflection. So we're not going to be rotating anything. So the green graph is 1 over x. So Michaela noticed that this graph typically has a part of it up here, this coordinate, and this quadrant. All right. So she noticed it reflected. So what happens? The y values all reflected. Okay. So that tells us we're going to have a negative out in front. All right. We got negative f. Now, after it reflects, does this graph move left or right? Left down. So this means how far did it move left? 2 units. So everyone see that because we know that this original function has a break right here, x equals 0, so it's moving 1, 2. And you see how it's sort of like that break right there. All right, so x, and how do I represent it? If I'm moving 2 to the left, how will I put? Okay. Now, you move up or down? Move down, how far? 1. Because typically, the break is right here along the x-axis, so now it looks like that break is right here along this line, which is 1. So I'll move down 1, so how do I write that? Minus 1. Okay, so let's write our equation now. So right now we have negative 1 over x plus 2 minus 1. Let's check if that's right. I gave you some points. I told you that when x is 0, this is equal to 2. So if I plug in 0 over here, I get negative, so if I plug in 0, I get negative 1 divided by 0 plus 2. 0 plus 2 is 2. So it's going to be negative 1 half minus 1. Negative 1 half minus 1 is negative what? Negative 1 and 1 half. Not negative 2. 4. Well, let's plug in negative 4. So if I plug in negative 4 in here, it's going to be negative 4 plus 2. That's going to be positive 2. All right? And I'm going to have, negative 4 plus 2 is going to be negative 2. 1 divided by negative 2 is negative 1 half. And then I'm going to subtract, so it's a negative sign, so it's negative 1 half. No, it's going to be positive 1 half minus 1. That's going to be negative half. So it's off a little bit. All right? So, I'm trying to figure out the best way to So, what this tells us is that this is all right. Except now it's, something that's stretched a little bit. All right? So, what you might want to do, we know this is all right. So we're going to try negative 2. Or not, we'll put a 2 up there. Let's say we're going to say we multiply this. Alright? Let's try 2. Alright, so that would change it to negative 2 over x plus 2 minus 1. So if I plug 0 in, alright, I get 2 divided by 0 plus 2. 2 divided by 2 is going to be 1, which is negative 1, minus 1 is negative 2. So that works out. And then if I plug in negative 4, I get 2 divided by negative 2, which is going to be negative 1. Negative 1 is positive 1. Minus 1 is 0. Alright? Typically, so our equation is right here. negative 2 divided by x plus 2 minus 1. How that, here, well, okay, so here's a couple things. Number one, on a test or a quiz or anything, I'm not going to give you something, I typically won't give you something that involves the reciprocal function being stretched. That's kind of neat. Typically, it will be x squared. Typically, your function will be working with x squared, square root, or maybe cube function.
Oh, so that shows that it's there.
Yes, that 2 shows that it was stretched. So typically, you guys will be dealing with something that is like not a reciprocal function. Alright? So, I need to do a couple things before class ends, so what I have to do is I have to pass out grade checks, pass out missing, or pass out work. Here's what needs to be done. I'm gonna give you guys homework. First of all, if you did not complete last night's homework, you need to complete last night's homework. You have 2 homework problems. Okay, and I'm going to tell you what they are right now. They're not on that paper. Okay? Your homework. Yes. You need to come to class. Alright? And what you need to have is on Wednesday you need to have 2 problems. Number 1, you need to tell me what the parent function is. So you need to create a graph and function that has one of these, or let's say 3 of these 4 things. Horizontal shift, vertical shift, stretch, reflection. Alright, so actually that's going to be number 1 and 2. All you have to do is create a function of your own using one of the parent functions, and you need to also graph it. And it has to have it has to have 3 of those 4 things. So for instance, I could say I want to do f of x is equal to 2 absolute value of x minus 3, plus 4. So there's my function. What you need to do is you need to tell me how it moves, and you need to graph it.
I already know.
Okay?
You stole mine.
You stole your face.
No. I swear you just stole mine.
Alright.